Welcome to Ancient World Studies. My name is Dr. Raoul McLaughlin. The question is, what does the Greenland ice core reveal about the Roman economy? Ancient miners crushed and heated large quantities of newly mined ore to extract silver and lead. This process, which generally occurred close to the mining site, was known as smelting. Roman smelting activity occurred on a vast scale, and the pollution fumes it released into the atmosphere can be measured by modern scientific analysis. Scientists have drilled into the Greenland ice cap to extract a record of ancient snowfall that was compacted into thin sheets over many centuries. The snowfall, preserved from the Roman era, contains minute particles of pollution caused by ancient smelting activities. This evidence provides a scale for determining Roman metal production over time. The evidence provides important information about the function of the Roman economy. The ice core evidence first became available in the 1990s. Further studies have provided extra detail, but the trends revealed by early research have remained intact. The particles of pollution detected in the Greenland ice cores comes from the smelting of silver and lead, which was often mined from the same sites. In ancient times, lead production was often a byproduct of silver mining, as the two metals were found in the same ores. Silver was far more valuable than lead, and this precious metal was often minted into small, high-value coins known as drachmas and denarii. A further important study, published in 1997, used isotope analysis to determine the origin of the pollution particles found in the Greenland ice cores. This article, published in the Journal of Environmental Science and Technology, was titled Lead from Carthaginian and Roman Spanish Mines Isotopically Identified in Greenland Ice. The study revealed that during the peak of ancient activity, up to 70% of the pollution found in the ice cores was coming from Roman mining operations in Spain. Later studies have confirmed that Roman mining operations peaked during the early imperial period and declined sharply in the late 2nd century AD. This decline corresponds to the Antonine pandemic, a virulent form of smallpox which may have killed up to a third of the ancient population in affected areas. I have devised and published a new model for the Roman economy called the Eastern Commercial Revenue Model. In this video lecture, I am going to discuss how the ice core evidence can be incorporated into this reconstruction. Firstly, the scale of Roman metal production. The ice pollution data is a proxy for ancient mining activity. It shows increases and decreases in the volume of ancient smelting, but source evidence must be referenced to suggest the scale of these activities. Pliny the Elder provides figures for a leading site in southern Spain called Babeco, which was producing large amounts of silver for the Carthaginians in about 220 BC. He reports that this mining site provided Hannibal with 300 pounds of silver a day, as tunnelling was extended 1.5 miles into the mountain. Output on this scale might have produced enough silver to mint 5 million drachma per annum, equivalent to about 20 million sesterces. Further evidence is provided by the Greek geographer Strabo, who describes expanded silver mining near the Spanish site of New Carthage in the 2nd century BC. His information came from the Greek historian Polybius, who was well connected with individuals at the highest levels of Roman government. Polybius was writing some time after the defeat of Carthage in 146 BC, when the Romans had claimed the Carthaginian silver mines in Spain. His figures report a possible peak in Roman silver production. Polybius died in about 118 BC, so the figures predate this event. Quoting Polybius, Strabo reports that the mines near New Carthage covered an area of 44 miles, employed 40,000 workers, and contributed 25,000 denarii to the Roman treasury per day. This suggests an output equivalent to perhaps 9 million silver coins per annum, or 36 million sesterces in Roman currency. During the 1st century AD, the ice core pollution levels did not increase substantially above the measurement for this era. This suggests that silver production during the early imperial era may not have increased far beyond the figure of 10 million drachma per annum, which is equivalent to 40 million sesterces. The isotope analysis suggests that about 30% of this pollution came from non-Spanish mines. This suggests that silver output from Roman Spain might have continued at about 26 million sesterces, with 13 million produced from mines in other imperial territories. Perhaps these estimates can be revised as new, more detailed evidence is revealed from the ice core record, but the current evidence is sufficient to suggest changes in mine output levels. The evidence suggests a major decrease in mine production occurred after the Antonine pandemic. In this period, Roman income from silver mines that had been worth 40 million sesterces per annum fell rapidly to less than 10 million sesterces per annum. The question is, why did precious metal production matter to the Roman economy? The Eastern Commercial Revenue Model suggests that the Roman economy was heavily reliant on newly mined precious metal to pay for its essential costs. Much of this expense was the cost of maintaining 30 legions, or close to 300,000 professional soldiers in permanent service to protect the frontiers and keep order among subject nations. The ancient evidence suggests that just over a tenth of Roman revenues came from mine production. But this precious metal had another important function in the Roman economy. The Eastern Commercial Revenue Model suggests that up to a third of essential Roman revenues came from taxing Eastern imports arriving through the Indian Ocean trade networks and the overland silk routes. This commerce was sustained by the export of Roman gold and silver coins and bullion, which paid for spices, incense, pearls, and silks in distant eastern kingdoms. The Romans produced both gold and silver coinage. Roman gold coinage was called Aurei, and one Aurelius was worth 25 silver denarii. There were gold mines in Gaul, Pannonia, and the eastern desert of Egypt, but the main bullion sources for the Roman regime were in the Iberian Peninsula, modern Spain and Portugal. Pliny the Elder served as procurator, governor, in Hispania Tarraconensis, so he had good knowledge of bullion production in Iberia. He reports that Iberia produced up to 20,000 pounds of gold a year, which is equivalent to 800,000 Aurei, or 80 million sesterces. This figure for gold production suggests that the Roman Empire might have been receiving mining income of over 120 million sesterces per annum. This would consist of gold production, worth more than 80 million sesterces, and silver output, worth a further 40 million sesterces. The Eastern Commercial Revenue Model suggests that this was sufficient wealth to pay the cost of more than 10 legions and their auxiliary support. Mine production could therefore have paid the expense of almost the entire Roman military presence in Western Europe. This included the essential Rhine legions, which guarded the Roman frontiers next to Germania. Support for this reconstruction comes from studies of Roman coin output. Modern scholars have estimated coin production in the Roman Empire by counting the number of unique dies used to strike new coins. They estimate how many coins might have been produced by a typical die before they became worn and were replaced. Multiplying the number of dies by the likely number of coin strikes produces an estimate for mint production. Using this method, the Cambridge professor Duncan Jones estimated that by the time of the Emperor Hadrian, the Roman mint was producing a probable 16 million denarii and 1.1 million Aurei per year. This is equivalent to 64 million sesterces worth of silver and 110 million sesterces worth of gold. However, a large proportion of this silver was possibly collected from older coinage melted down for reissue. What is important is that these figures are consistent with the mine output suggested by the ancient sources and the ice core data. Modern estimates for Roman state spending provide context for these figures. A generation ago, the Cambridge professors Duncan Jones and Keith Hopkins devised source-based estimates for Roman state spending that have formed the basis for most modern debate on this issue. Their studies suggest that essential state spending by central government increased to more than 900 million sesterces during the early imperial era. This may be an underestimate. Based on revenue evidence, the Eastern Commercial Revenue Model suggests that imperial revenues could have been as high as 1,000 million sesterces, or 1 billion sesterces per annum. The large-scale production of new coinage stabilized the Roman economy and counteracted the effects of Eastern commerce, which relied on exported bullion. Pliny the Elder was part of the advisory council convened by the Emperor Vespasian. Writing in his encyclopedic Natural History, he reports, "By the smallest computation, India, the Chinese, and the Arabian Peninsula take 100 million sesterces from our empire every year. This is what our women and our luxuries cost us." In the early imperial era, this export was counterbalanced by mine production. High-level mine output therefore ensured that the Roman economy was not drained of the precious metal it required for its essential currency. The Roman state could not impede Eastern trade or restrict the export of bullion because of the enormous customs revenues it received from taxing imports. The Eastern commercial revenue model suggests that in Egypt, the taxes collected on Indian Ocean trade amounted to more than 300 million sesterces per annum. A large part of Roman state revenues were therefore generated from finite mines or the export of unrecoverable precious metal in international trade. Most provinces produced little surplus revenue for the Roman state, and many territories were a deficit due to their essential military expenses. This meant that mine output and commercial revenues were crucial to the successful function of the early empire. The Eastern commercial revenue model provides a context for the Antonine pandemic and the ice core data. The disease had a greater potential to harm the Roman economy than most modern scholars acknowledge. The emperor, during this period of crisis, was Marcus Aurelius, who spent the last decade of his reign campaigning to counter Germanic threats on the northern frontiers. He faced the challenge of how to defend an empire depleted of troops and deprived of its organizational capacity by an unrelenting force of nature. But the emperor also became famous for his personal writings on Stoic philosophy. The Meditations was written during this period of crisis and explores concepts of duty in response to extreme adversity. Ancient authorities identify the period after the Antonine pandemic as a transition point in the fortunes of the empire. Dio Cassius explains that after the death of Marcus Aurelius in AD 180, the history of Rome descended from a kingdom of gold to one of iron and rust. The golden age of the empire was over, as long-term revenues faltered. Consequently, the silver coinage, which had formed a core element in the Roman currency system, was reduced to an increasingly low-value debased token of imperial propaganda. If you want to know more about the Antonine pandemic, you can view my lectures on YouTube or listen to the Queen's University podcast by Dr. John Curran. The Eastern commercial revenue model is explained in my books on Eastern trade. You can find a link below to my academia page, where I will be uploading this new research. Thank you for your attention.